Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi guys, so let's continue with identifying seasonal components via multiplicative models. Here, a multiplicative model says that we should multiply the actual figure with the trend to get the seasonal component value. Whereas the additive model said to minus the actual from the with the trend. Okay. So the same example, let's consider. So seasonal variation equals actual minus divided by the trend, where actual stands for Y and trend stands for T and seasonal variation stands for S. Okay. So since it's like the previous question, these two parts are similar up to here. So I'm going to copy paste it from our previous workings as it saves more time. The same method should to be followed. Now what changes is the seasonal component calculation, where you have to divide the actual by the trend. So 94 will be divided by 92 here, and same thing you continue for the other figures. Okay, and reduce it to 2 decimal places or 3. Fine. Next step is similar to the additive model, where you have to get the summary of the seasonal component and obtain the average per day. So what we got to do is find and then the average. It has auto calculated using the same method. Let me verify if it's correct. Yes, it is. Alright. Since we have the average, the next step is to estimate the final and the estimated average. And finally, we got to calculate the overall trend. Same steps to be followed, but there's a change. Okay. So the estimated variation is identified in step 2. You have to copy paste the same thing here, which is in, yeah. Alright. And then it totals up to average 5.5 something. But this time your adjustment, instead of being to 0, you should adjust it to 5. The reason is because you have 5 days here. That's why the total is now nearly 5. It must be exactly equal to 5. So for you to do that, you should first of all take the difference between this and this 5. So it's this much. And then so if you divide this is for this difference is basically for 5 days. So divide by 5, you get something of this amount, which you have to basically reduce. Isn't it? So if you reduce, yes, you get a total of so you can reduce these to decimal places as they should. and then get your final estimate, which is the gap between this, where your total of the final estimate must be equal to 5. Okay, remember that. That's the goal. Why 5? Because there are 5 days as per the question. Okay, finally you have to calculate the overall trend. In calculating the overall trend, you first select the trend of the last day and compare it with the trend of the first day. Get the difference, then there is a small change we have to do. So the last day's trend is 99.2 same, first day's trend is 92. So it remains the same and it's an increase. However, this part gets deleted off, then you get the difference in percentage terms. In getting that, what you do is divide the difference by the first day's trend and multiply the entire thing by 100%. Then you will be getting 7.2 divided by 92 multiplied by 100. Okay, which is 7.82%. Alright. Or else what I would do in this Excel, I would basically ignore the 100 and give it the percentage mark. Okay, 7.83 will be your difference in percentage terms. Now this difference in percentage, divide it amongst the number of periods between the above trends. So the number of periods between the above trend is 10. So the same thing, only difference is that we converted the difference into a percentage. That's it. Next, you have to simply take 7.83 and divide it by 10 days or 10 periods. Okay, which will give you, sorry about it. So it will give the answer in percentage. Zero 0.78%, 0.78% increase per day. Alright, so that will be your trend increase under the multiplicative model. But the trend increase under the additive model is 0.72, but under multiplicative model you converted 7.2 same thing but into a percentage just to reflect it in percentage terms, but it's the same thing. Okay, mostly the same because here only difference is it changed to percentage terms. Okay, so make sure you follow these steps so that you will not get it wrong. Okay, so with that we finish calculations for multiplicative models as well. Next, let's see how to get seasonally adjusted data. Now it's an interesting thing where they will give in the question the daily frequencies like this. Okay, so what we are supposed to basically do is so what these figures are, it is coming from here. this seasonal component that we calculated under each model, that is what they have given in the question. See, same thing. In multiplicative model, there is no plus or minus. Why is that? Because everything takes the addition and the average and it's a division. So in multiplicative model, there won't be signs of minus. Alright, but that is not a problem or a concern. What we got to do is now deseasonalizing the data. That means we have to remove the seasonal adjustment and show the trend figures. To do that, first under additive model, we must remember that seasonal variation equals actual plus the trend. So if we are to find, now they have given us the actual, which is actual sales, and they have given us the seasonal. Therefore, what is remaining to be found? Remaining to be found is the trend. And therefore, trend only will be known as deseasonalized data. Trend equals S minus Y. Reflect how you do this by making the missing one as the subject, as how we learned in equations chapter. So you have to minus the seasonal effect from the actual to get the trend. Okay. So basically it will be, we can reword it as Y minus S. Okay. Alright. Because why I put it Y minus S is to consider the plus and minus adjustments. So you all just remember it should be Y minus S. You all will get as I do it. So but just remember it should be Y minus S. Whereas the let's put the multiplicative model. Model says that we have to this is originally y divided by t, but when we make t the subject, it becomes y multiplied by s. Y divided by s. It basically becomes y divided by s. Okay. Alright, let's now work out the calculations. So I'm going to put the data and I'm going to put the sales actuals, which is 150, 160, 164 and 170, and then we have the additive model. So let's create two columns for it, additive, multiplicative, and let's say seasonal and the trend. Okay, and let's put the marks symbols. This is Y, this is S, and this is T. Again, this is S and T. Okay, let's put off the trends given. Plus 3, plus 4, plus 4, minus 2, minus 5. 1.02, 1.05, 0.98 and 0.95. Okay. Here, additive model. To find, I have put it in the wrong column. Okay. To find the trend, you get the difference between the actual and the seasonal value. Just get the difference. Now when it comes to this situation, it is 164 minus 2. Then it becomes 166 because minus and minus is plus. Okay. And then for multiplicative, we divide the actual by the seasonal amount. Then we get the trend. Alright. So you see the additive model trend and the multiplicative model trend. This is called deseasonalized data. So if they ask in the exam or asking for deseasonalized data, you must remember these two formulas according to the model given. Oh, okay. Remember that very well. You could have hints. If it is just a plus minus thing, surely it must, if it has minus, surely, surely it must be an additive model because there isn't minuses in moving average. So there can't be a minus when multiplying during or dividing during a multiplicative model. There can only be a minus when there's an additive model. So make sure you, that is a hint you could use in the exam to check if the figure seasonal adjustments or seasonal components given are additive or multiplicative. Fine? Alright. So with that we finish deseasonalized data. Next we can look at forecasting time series data. This is super easy. We can use the same formula example that we used previously, and it's just an extension of this table. This particular table that we prepared. Now forecasting means we are going to forecast from week 3 end onwards. That means after Friday what would be the figures. This part is for forecasting. Basically week 4 will be a forecast. Okay, that means predicting the future. But our trend, our moving average and trend stops at Wednesday of week 3. Because it stops at Wednesday on week 3, that we have to start forecasting from Wednesday. Okay, I'll show how it's done. So, name this as forecasting. Okay. So I'm gonna take this for the additive model first. All right. So there are 3 steps to be followed when making a forecast. The first being identifying the trend. You identify the trend upon 3 methods which was discussed in previous chapters as well. That is the line of best fit, linear regression or moving averages. Secondly, you extrapolate the trend line. That means you extend the trend line outside the range of known data and forecasting the future results from historic data. Okay, that means you take the last line. I told you that I will be selecting the last day where the trend ended, which is week 3 Wednesday. So let us write week 3 here, and before that let me center these, week 3 and Wednesday. So we have the actual, but this basically is not necessary. But we might need one column. So I'm going to remove these two columns, and instead of trend, in addition to the daily trend, I'm going to write past trend. And then we are going to estimate this for another week. So I'm going to put Thursday, Friday, and then Monday to Wednesday, Monday to Friday again. So the past trend on Wednesday was, well, we shouldn't say it's a past because it's the final. So there isn't a there isn't a change here. So I would say this as change in the trend, so that it's more clearer to understand what we are doing. And I would say that this is plus the change in the trend. Okay. Now, for Wednesday, under the additive model, trend was 99.2. Now, this will be the past trend of Thursday. What was the change in trend we found under additive model? It was 0.72 increase per day. Then put that 0.72 to this cage. Since it is an increase, you must add. Okay. And then it will become Friday's opening past trend. But 0.72 is fixed. So fix it for all the other days and then keep adding it. That's all you need to do when you forecast. Okay. So this is what you basically do. In this way you add everything and get the seasonal component. Now seasonal component is S, isn't it? This is stands for S. Whereas this stands for the trend. Now what's the additive model formula? Seasonal component equals actual minus the trend. Then actual will be equal to, if you make actual, which is y, it will be equal to s plus t, isn't it? So now let's rename. Now this y, we reflected the past trend. Now let's put it as p here because as past. Okay, p, and let's rename this as the trend line. Okay. Actually, this is the past trend. This is the change in trend, CT, and this will be known as the trend line. Alright. Then we will have another column for seasonal component and then the actual. Seasonal component and the actual. Actual stands for Y. We know under the additive model that S equals actual minus the trend. Okay, the seasonal component. Now for this seasonal component, we go back to our additive model and we have to extract this final daily variation estimate. Okay, the step 2 basically. Step 2 of the additive model figures must come here. Fine. So you basically copy paste it here. So Monday's additive model variation is minus 13.06, right? So you put minus 13.06 plus 15.94 for Tuesday, but plus 1.34 for Wednesday, Thursday plus 28.24 and minus 32.46 for Friday. Then okay, so here this one you could ignore because it already has a component. But for Thursday it will be 28.24 and Friday it will be 32.46. Now estimate the actual. If the additive model says S equals actual minus the trend, then if we make actual the subject, it will be seasonal plus the trend. So seasonal is this, new trend is this. So the actual will be trend line plus S. Alright. So you see step 2 in additive model comes in here. Step 1 of the additive model comes in here. Step 4 of the additive model comes in. You see how it relates? And that's how you get your answer. Then this S is equal to, well, it's equal to the step 2 answer. So this Y equals to S plus the trend, new trend. I'll name this new trend. Alright. This is the table you should follow for additive models. And now you see you forecasted. This is a forecast of the future actuals that you can expect on a Monday to Friday calendar. Fine. This is what they would ask in the exam. So they will give this change in trend probably. So you should be able to find and the seasonal component. So you must apply those variables into the table and calculate the trend line and the actual. Those two only you must calculate additionally. The rest, the information is already given. And this is the continuation of the new trend. Alright. Fine. So with that, one thing to clear, this is not necessarily step 1, but kind of connects to step 1 because of this 99.2 coming from Wednesday. Apart from that, it's a continuation of whatever that gets added to the change of the trend. Fine. Next, let's go to the multiplicative model, which acts in the same manner but a bit different. Okay, so in the multiplicative model, your actual, so first we have to set these formulas, then it's easy to work. Past trend is, well, there's nothing here for Wednesday because it's the last day of the trend we predicted as per the given information, which is 99.2. Same, and this gets continued for Thursday's past trend. And so on, the formula works. Fine. So I'm gonna drag it so that it saves time. Now, the change in the trend for a multiplicative model, which is in step 4, we noted that it's a 0.78% increase every day. Remember, it is every day. So 0.78% increase means 99.2 must be multiplied by 1 plus 0.078 in decimals. Isn't it? Because 0. actually 0.078, because 0.78 percentage means if you 0.78 divided by 100. I have told you all previously, if it's divided by 100, you move 2 decimal places backward, then you get 0.0078. And I have told you all in the first lesson, first chapter, that if you are to apply an increase to something, you must add it by 100 percentage. So this 0.78% plus 100% will be equal to, 100.78 percentage, isn't it? There's something wrong here. 100.78 percentage. This divided by 100 will give us 1.0078. That's what is here. Okay. So 99.2 multiplied by 1.0078 will give us the new trend item. Then apply the same and multiply. Alright. So the difference here is the trend line, it gets actually multiplied to the change. Right? Actually the past trend gets multiplied to the change. So the reason is because it gets added divided previously. That's why it is now getting multiplied. Now get the average final seasonal variation found under step 3 in the multiplicative model, which is this. For each day, what is the seasonal variation or the estimate? Same thing, categorize on Monday, Tuesday is this, Wednesday is this. These are the seasonal effects for each day. What you should do here is, here you have to change the sign to multiplication. So it is S multiplied by the trend, which is seasonal component multiplied by the trend line. So you multiply your seasonal component by the trend. And get your actuals. Tuesday, is it 0? Or we made a mistake, isn't it? Okay, there's a formula mistake, but let's multiply by this. Yeah, so there are decimal changes here. So as you could see, the only difference between the multiplicative model and the additive model is that the trend line, the basic new trend line calculation and the actual calculation is different, plus the seasonal component. Other than that, everything else is similar. Why you should know what is only changing? Because they will give in the exam these details. So you should be able to identify quickly what to calculate and what to extract from the exam detail and basically get the figures. So reflect on this, understand the difference, and in forecasting the actuals for each day. So in summary, again what we did was, we first identified the variation for each day. Then we adjusted it to our trend and got the actual. That's all. So trend is usually calculated by moving average. As previous method, we found what is the daily moving average and is it an increasing average or decreasing average. And we found out that it is an increasing average. as per step 4 in the previous calculation. Because it's an increasing average, we forecast an increase because it's forecast. No? That's why we apply continuously increase, but actually there can be decreases here. But for the exam, if it is increasing the beginning until the last day of the actual trend, then it should be the same until the forecast in the forecasting period. Apart from that, there is nothing much to note. That's it. And then make sure you get your data right and make very sure that this new trend equals the past. In additive model, it is past trend plus the change in trend. If it is an increase, but if it is a reduction, then it's past trend minus change in trend. Whereas in the multiplicative model, it is always past trend multiplied by the change in trend will give the new trend. Whereas the actual will be seasonal component of the multiplicative model multiplied by the new trend. In that manner, you will get your actual under the multiplicative model. Moreover, the change in trend must be the extra addition to 100%, and it should be in percentage terms. Then only you will get such components, and the change in trend must be multiplied to the past trend. Once again, a reminder. So work out these workings again by yourself and attempt revision kit questions. They are very similar. That's why I didn't choose to do it. What you mainly have to focus is on your formulas. So don't go away from formulas. Stick to the formulas. Then the chance of making a mistake is less. That's why. All right. Okay, let's just look at the limitation of forecasting. So it's just a forecast, we cannot rely on it. And if we have only less data to make a future prediction, then also it won't be more reliable. And the patterns of trend cannot be guaranteed because, of course, like COVID, something suddenly comes up, everything changes, the trend changes. And there's a danger of random variations upsetting. So random events like tsunami or COVID can upset the pattern of trend. The extrapolation of the trend line, that means extrapolation of the trend line means we used the action of, basically it's the action of using the last day's trend and extending it to next few days. That type of action is called extrapolation of the trend line, and it is done by judgment and can introduce error. Okay. So in business models, basically, so this is what they do in business models. They use it for, birth rates, to check the birth rates if it's coming to demographics, and if it's like a government related stuff in demographics, or sales, seasonal sales. In the exam, probably about sales factors, they might give the question asking you to calculate the trend, or they might not actually ask you to calculate, but they will ask you to comment. So is this an increasing trend? What is the seasonal effect? Is it a big effect or a small effect? So 33.2 and all is a big effect of seasonal, but it's a minus effect. That's how you got to comment. All right. Um, all right. So this is it from chapter 12. Next we will meet with a question series of revision.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.